Hey guys, so the other day I got in a '06 Mitsubishi Lancer 2.4 manual transmission. It was in for a no start. Turned the key, wouldn't get anything, no click, nothing. Uh, Once in a while, if you got lucky, it would actually start up. So what I do to start off with, to at least get initial direction, before I even really look at anything, I get a buddy in there, hold the key to the start position, while I'm checking the S terminal of the starter. If it's accessible. In this vehicle, it's actually pretty accessible. Uh, so buddy cranks, I check, I get no power. Immediately I'm starting to think supply issue. Right away I'm thinking um, ignition switch. It feels like an ignition switch. You hold it, you hold it, you hold it, nothing. But once in a while it would fire up. When it does fire up, it fires up normally, as you'd expect a normal vehicle would. But without assumptions, I just grab the wiring diagram, just go into it, do your checks, and see what you find. So grab the wiring diagram, and we just check as expected. Older vehicle, simple. Just got the battery, the fuse for the ignition switch, the relay, clutch pedal switch, and the starter. So with all these systems, you got your relay, it's got your two power feeds, your starter load side, and the ground side switch of the relay is your clutch pedal. So let's go find this relay and do some tests. Here's the underhood fuse and relay panels. We see for this guy here, there's only 3 relays. We look here, looks like a rad fan, fog lights, horn, so not in this section. Up here we have an engine. Over here we have another engine. There's two. These 3 are all blank. There's no pins in them at all. So these guys here would be for an automatic transmission. This would be for some security or something. Who knows? We don't care. So we got another relay here, which is a engine, and then over here we have AC. So we have 3 candidates for the starter. Let's find out what's what. Pull up a picture on all data, and down here we see starter relay manual transmission is the first one closest to the check terminal, so that would be this guy, relay A. So go pull it out, and we see just a standard 5 terminal relay. We have the 2 load sides, one will be the 30, one will be the 87. We have the 2 control sides, one will be 85, one will be 86, and then 87A. We go here, so this is the supply to the relay, which would be your 30. This is 87, which would be the feed to the starter. 2 control sides, so one of these is going to be a power feed, and the other side, the ground side switch, is going to come from the clutch pedal switch. Just standard stuff. Then we look at the socket to do the testing. What is that? There's no terminal in there. This is where I start getting an inclination that, hey, this isn't a standard vehicle. This isn't just the way it normally does it. Because that is 87. That's supposed to be, the way most systems do it, supposed to be going to the starter. That's not damaged, that's not ripped out, that was never there. So this vehicle is doing a different setup. So we'll do our tests, no big deal, we'll just figure out what is what. So we hold the key to the start position, we should see 2 powers. Sure enough we do. see one power here, and then one power here. So I'd have to assume that the starter would be the large terminal. So when we check here, the relay out, we should see ground. Sure enough, we do. So that's ground. So these are our two powers, the top two. So the bottom one should be the ground side switch from the clutch pedal. Now relay out, I shouldn't see anything because the switch is open. When I push the clutch pedal, I should then see ground. What I found using test light is that when I did not push the clutch pedal, I got a ground. When I pushed the clutch pedal, the ground went away. That's weird. So I'm thinking right away there's an issue with the circuit for the clutch pedal. I don't know why it's doing that, so let's just go after that. Let's just see what we see. We'll do some tests right at the connector for the clutch pedal. So I open it up, pull the knee bolster off, and I see these wires, aftermarket junk. Security system, remote start, probably not remote start. Who knows, maybe it was a keyless entry, it's something. When I look at the wires from the ignition switch, I see a couple that had tons of tape all around it, and they're bulky and they're ugly, and I'm thinking, okay, they spliced into those wires and the splice came apart, because when these are installed, they're never installed well. I open up the tape, and what I found was all they did with these wires here is they just peeled back the insulation and then they wrapped these around and put electrical tape around. So they never cut the factory wires. It's not great for the factory wires, but they were still intact, so this wasn't the issue. For grins and giggles, I decided, hey, with it off, let's try it. Sure enough, didn't start. So we were going to go after the clutch pedal switch. Let's do that. It's a little ugly to get to on this vehicle. It's kind of behind this fuse panel. So I unplug it. You really got to crawl in here, as you do with most of these. And it's this connector down here. So we're going to figure out why I had the ground, was it unplugged or was it unpushed, and the ground went away. So we get our connector. Now, looking at this, on the red wire, that should be your full-time ground. I check it, sure enough, full-time ground. On this wire, I should have nothing. Now, when I did this check, I'd put the relay back in because I wanted to check to see if it would start after I pulled those wires off for the when I pulled these wires off, right? So I wanted to see if it would start. So I put the relay back in. But no big deal, because the key's not in the start position, so there's no power here. So when I'm checking on this white wire with this unplugged, I can go through here, up to here, that's an open circuit, and go down here, that's also an open circuit. So even though the relay is in, I should not see anything on the white wire at the clutch pedal connector unplugged. But when I test here, I see a ground. So there's ground on both wires with this clutch pedal connector unplugged. Now, this is really making me second guess everything, because when we put it in the start position, I got a power here, I got a power here, I got a ground here when the pedal's not pushed, but I'm not getting anything down here. So I'm thinking that, hey, maybe the clutch pedal or something is shorted here. Let's try starting it without pushing the clutch pedal. Maybe this is really weird and buggered, and it's going to start. I do that, and it did not start. And again, I'm remembering that occasionally it would start, but I'd have to actually push the clutch pedal. So that's not falling in place. So I'm really second guessing everything. So I decided to go back to the relay socket, and let's put full-time power here manually and see if the starter bumps. There's no computers anywhere, so we don't have to worry about anything like that, jumpering power there. Sure enough, I do that, and it starts every time, or at least tries to. I don't get it to fully start, I just bump it. But it'll bump every time right away. So we know this whole circuit, including the starter, is fine. So now we're really guessing everything, because why, if I have power here, if I have power here, and if I have ground here with the clutch pedal not pressed, why am I not getting power here? Why is this not starting when this is capable of starting? So again, what if I had the terminals wrong? What if I assumed they were a certain way, but they really weren't? So let's do more testing. Now, if we test at the relay socket, these two wires here, with the clutch pedal not pressed, with the starter in the off position, two of these pins should have continuity. These two right here. Assuming they should be the ones that I got the power on. And sure enough, when I test these two here, they had continuity. Now, nothing else should have continuity with each other, because these two wires here, with everything off, they don't go anywhere. This one here goes to ground, but this one here goes to nothing because the clutch pedal is not pushed. So nothing else should have continuity. I check between this, every which way. What I found was this guy here and this guy here also had continuity. Why? Because this guy here goes down here, goes to ground, and it's not going to have anything through engine control system, because it had quite low continuity. I think it was like 0.8 of an ohm or something like that, not very much. And this guy here goes to open circuit. Should be no continuity. But between this and this, I got continuity. So now, let's do some checks at the relay. Maybe the relay is bad. Maybe something else is bad. Maybe everything is bad. So we look down here, this one's empty, so we don't worry about that. So we should have a resistance value between the control side. I checked that. I think it was like 170 ohms. It seemed a little bit high, but nothing excessive. And then you got our load side. Now these should be open unless it's activated. I check it for resistance, and there's no resistance. It's complete dead short. So I'm thinking, great, we got some issue with the clutch pedal switch. It's working backwards, and the relay is shorted internally. Let's get a new relay. So before we order one in, we find one in the shop that's the same dimensions, same pin layout, all that. And this isn't the exact same relay, but the relay that we grabbed had a diagram on it. Now at this point I wasn't thinking in relay terms, I was just thinking to see what we had, what I could test. But when I saw the picture, boom, it all came back. Of course, these two pins had continuity. This is 87A and 30. They're supposed to have continuity when the relay is off. Now we're not using 87, so these two are our load side terminals, but when the relay is off, they're supposed to, by relay standards, because this is just a regular relay, they're supposed to have continuity. So I don't know why the wiring diagram doesn't show that, but the wiring diagram's wrong at this point. So now I'm thinking, well, the clutch pedal switch probably isn't wrong because that seems far-fetched. So I don't know why it's doing what it's doing, but let's not worry about getting a new one yet. Let's go back to ultra basics. So this guy here I know goes to the starter. So let's put manual power to it. There's nothing else involved. There's no computer that we really have to worry about because this, although this isn't the main power feed to the starter, this guy here does not get the full, say, 150 amps going down it. It still gets a solid 30 to 50 amps of current while it's pulling the solenoid closed. Once it's closed, holding it in, it's only using about 10 amps. But still, that's a lot of power. So we don't have to worry about this. This circuit's capable of handling a lot of power. So we can manually power that just fine. We won't have to worry about anything being damaged. So I attach power to it, and it bumps over, it turns over every time, right away. Bump, 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 crank, 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 crank. So now we know that all of this, including the starter, is totally good. There's no problems with that. So I don't know why the clutch pedal is doing what it's doing, but you know what? I know the starter's good. I know it's capable of starting, so we gotta go with ignition switch. We just have to. So I open it up. Here's the ignition switch. This guy here, the black with yellow trace, that is the wire coming out of the ignition switch contact that is feeding the relay. Now I know I had power here when I did testing, so I really should be fine. But what the heck? Let's test it right at the switch. We got to do something. So at this point, this was also one of my mistakes that kind of turned this into the hassle that it was. When I was testing at the relay, when I was testing, so for this guy and this guy looking for my powers on this guy and this guy is where I found them, I was just using an incandescent test light. You know, it's 350 milliamps of current. For most things, that's fine. Again, this guy's about 50 amps. Should have been fine. I did have power there. Maybe it was dim, but on the other token, this guy would eventually start once in a while. So maybe when I was testing it, maybe it's when it was working. And then when I tested it at the ignition switch itself, I used one of my homemade test lights, if you will. It's a 2 amp bulb that has a couple of banana connectors on it. And I use a back probe, and then I go to crank, and I'm right at the ignition switch. Now, it did seem a little dim, but I definitely noticed once every 5 times or so there'd be no power coming out at all. The test light would not be lit. And then what if I pushed here, I'd have power every time. If I go to turn it and I have no power and then push here while I'm holding it and start, the test light would light up. So okay, I got thrown down for a loop, I got sidetracked, I got lost, but it's just a simple ignition switch. Just throw it in there, be done with it. Sure enough, I throw it in, starts every time. After I calm down a little bit and I get a chance to step back and really think about it, then I figured out what was happening and why why everything went so wrong. Part of it, here's the life lesson, is part of it is just my assumptions. You do so many of these, whether it be a horn, whether it be a fog light, whether it be whatever. You do so many of these relay testings that you go quick, 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 especially when you're on the clock. And 99% of them are a certain way, and you expect it to be that way. And when it's not that way, you can go down a loop. You can also go down a loop when the wiring diagram is wrong, or you get wrong information. Now, I got this diagram from Mitchell. I like Mitchell wiring diagrams. I find they're nice to follow. They're good roadmaps to work off of. They're not OE diagrams. So someone looks at the OE diagrams and reformats it to give you these diagrams, which to me, I like more because I find they're better laid out, but they don't always have all the information. Typically what they don't have is they don't always show connectors. So between a circuit, there might be some connectors which would be easy to test at, and you might not know about them on one of these diagrams. Occasionally they can mislabel colors. For the most part, they're pretty good, but in this case they did things, they weren't very accurate. What this vehicle actually does, which also is kind of weird, is that's the way the diagram should be. This relay does not use terminal 87, so it does not have a contact when the relay is closed, which is right here. This would be terminal 87. It uses 87A. So it kind of works backwards. When you close this relay, internally it connects terminal 30 to 87. 87 doesn't go anywhere. So when this relay is closed, it opens the circuit. And vice versa. The clutch pedal switch. When this clutch pedal switch is not pushed, it is a closed switch. It's a normally closed switch. So that's why I was getting the ground on both sides, up here, when I was testing. So this guy right here. When I was testing here, I would get a ground with the clutch pedal not pressed because it is normally closed. When I was testing both these wires here, I had the relay in. The reason why I got ground here is because, again, it uses 87. It's normally closed. So what had happened with this unplugged on the white wire, it went through here, through the relay, up here, down here, through the relay again because it's 87 and 30, which are normally connected, and down through the starter and to ground and back here. So that's why I was also, when I did my continuity checks between here and here, so from this way, it went this way, I got continuity, but also a little more resistance because it was going through the starter. So typically, the way one of these works is you get your ignition switch. It provides powers. This is 30. Say this is 85. The clutch switch closes. It provides the ground. Activates the relay, which closes the contacts. Then your power goes through. That's the way a normal system works. You get your feed. It gets continuity when the relay is activated. This system here is different. This system has continuity when the relay is not activated. So you put the ignition switch to the start position. If you don't push the clutch pedal, the ground comes up. The ground will activate the relay, which will open the circuit. and no power goes through. You have in the start position, then you then push the clutch pedal. It will open the clutch pedal circuit, close the relay, or deactivate the relay because this becomes open, and then this closes back to 87A, and then you get continuity. Why they do that, I don't know. Maybe their line of thinking is that, hey, if there's an issue with the clutch pedal switch or anything like that, then this relay is still going to be closed. At least you'll be able to start the vehicle, I guess. Doesn't seem like that's a great way. This clutch interlock switch is supposed to be a safety item, so you don't start it while you're in gear and run someone over. Incidentally, if you wanted to test this an old school way, on this circuit here, this setup, you could unplug the clutch pedal switch and it would start every time. Because unplugged, you won't get a ground here. The relay will never close. It goes through 87A and boom, it starts. Now, a lot of old schoolers, what they would do is they would just unplug this and just jump at the two terminals to bypass the clutch switch and see if she starts. If you did that on this vehicle, it would never start because you'd always be activating the relay. You'd always be opening the relay, connecting 30 to 87, but 87 doesn't go anywhere. The system wants 87A and 30. So yeah, you just done so many vehicles of relay testing, you fall under the assumption and you get used to doing things a certain way that sometimes you forget that it doesn't have to be that way. Vehicles can do whatever they want, really. And then you have to keep that in mind, and sometimes when you see something different, sometimes if you're not open for it, if you're not willing to accept that it may be different from norm, yeah, you can be taken, and sometimes you need to be humble. Anyways, hopefully this could be of use to some people, and I will continue sharing items when I come across neat and interesting things, and leave a comment if you want, and have a good day. Thanks a lot. Bye.